Hello everyone, welcome to the Dementia Researcher podcast. With me, I'm your guest host Quang Tran, and we are live from the last day of AAIC 24. So, a bit about me, your guest host. I'm in the Science Communications team at Alzheimer's Research UK, and my job is just to make exciting dementia research as accessible as possible. And what guests we have to do that today. So, welcome both. Thank you, well, three of you. Thank you all for coming. Let's start. Let's do some introductions, shall we?
So my name is Joe Butler, and I'm based at the University of Sunderland in the northeast of England, where I'm currently an NIHR Applied Research Collaborative Fellow. And I'm working on remote digital tools for the assessment of Alzheimer's disease.
Oh, wow.
So that's also the poster that I presented on Monday, where we remotely collected data using our digital biomarker, the visual short-term memory binding task, and then used machine learning to identify the predictors of performance on what influences how you perform on this task, whether you're a good performer on the task or whether you're a poor performer on the task.
Excellent.
Yeah.
Amazing. And you are?
Yeah, I'm Shea Andrews, so I'm an assistant professor within the Department of Psychiatry at the University of California, San Francisco. And I'm a genetic epidemiologist, so a lot of the work in our lab is looking at how genetic, environmental and social drivers of health influence the pathogenesis of Alzheimer's. So my lab had several posters here at AAIC, so on Tuesday.
Cool.
Yeah, I mean, my data analyst, Anna, she was presenting a poster looking at the ancestry-specific effects of APOE on biomarkers and other AD risk factors. So we've previously observed that there's ancestry-specific effects on clinical diagnosis. Is this recapitulated in other biomarkers and whether that could then affect biomarker tests later on? Okay. My RA, Adrita, she was presenting a poster looking at making a biomarker for mitochondrial dysfunction based off mitochondrial DNA. So this is like our little tiny wet lab project. And then yesterday I presented my poster. So this is looking at how we can integrate genetic risk factors, so monogenic, polygenic risk scores, family history with clinical risk factors, with the idea that we could provide patients and healthcare providers with a genomic-informed dementia risk report saying, this is your genetic liability for Alzheimer's, and these are the clinical risk factors you have that you can intervene on to promote brain health. And critically within all this, making sure that this personalised medicine approach is equitable, so is generalisable across diverse populations.
That's great, yeah. I think you've got some really popular topics from this year's AAIC,
yeah.
So it's got great back there.
That's how you get funding.
Great. And this is Roberto on the end here.
So I'm Roberto Guzmán Hernández. I'm originally from Puerto Rico, currently based here in Philadelphia. I am a fifth-year PhD candidate in Dr. Silvia Fossati's laboratory at the Lewis Katz School of Medicine at Temple University. My interests are mostly in tau and the vasculature, and I presented a poster yesterday that looks at the effects of protofibrillar tau inducing metabolic alterations in endothelial cells. That leads to pro-inflammatory phenotypes culminating in a loss of barrier resistance. So that would be sort of previous to the widespread blood-brain barrier damage that we see in AD. Yeah.
Brilliant. Okay, well, I think that's intros.
Oh, and I'm an ISTAART Ambassador for this year.
An ISTAART Ambassador?
Yeah.
Oh, great. And repping the T-shirt
I'm repping the purple shirt, yeah.
Oh, I see. Oh, wow. True ambassador. Very nice.
Of course.
All right. Okay. So that's the intros done. I think now let's go talk into about our highlights from the conference. Let's start with Shea. You talked a bit about risk factors and things like that. That's been really popular, this conference. Has that been one of your highlights?
Yeah, definitely. So the Lancet Commission put out their new report yesterday. So they've previously done one in 2016, one in 2020, and now this is the third version of it.
Yeah.
So they've identified 2 new novel risk factors that they think can be intervened on. So this is LDL cholesterol levels and visual loss. So previously they had another 12, like educational attainment, BMI, air pollution. And they looked at the prevalence of these risk factors across the population and their relative risk to estimate the population attributable fraction. And this is if we could remove all these risk factors, how many dementia cases could be removed essentially or reduced. And they estimate, if we got rid of all 14 of these risk factors, we could remove nearly 45% of AD cases. So this again, like really highlighting that while we have these therapeutic drugs, also population-based health strategies, so statins, having mandated educational attainment, factors like that can really drive dramatic reductions in risk. But I think the other thing that they really highlight that this isn't equal across communities. So particularly different countries have different risk factor burdens, and even within a country, different racial and ethnic groups have different, again, risk profiles. And also, I think as was really highlighted in the plenary lecture, differences across educational attainment and socioeconomic status. Like that has a huge effect on the kind of risk factors we want to be looking at to design like those personalized medicine approaches.
Great.
Yeah.
So yeah, let's talk more about that. What did you think when you found out that it could be, well, in this study in particular, up to 45% of cases?
Yeah, I mean, we've already seen this declining incidence in the rate of dementia. Like prevalence is still increasing because we're having an increase in the aging population, but the actual incidence itself is decreasing. And potentially this is due to better cardiovascular health profiles and also better educational attainment, particularly among women within that age group. So yeah, I think it really highlights that primary prevention is really the way that we can reduce risk, not just this tertiary prevention using like monoclonal antibodies, which have huge costs and definitely aren't available across worldwide populations. Like they're really designed for high income countries rather than low to middle income countries.
Yeah, it was. I think we found it, particularly people at Alzheimer's Research UK, we found it very exciting that we can present up to half of these dementia cases can be prevented for like all the different steps that you could take to do them. There are 14 of those.
And most of them have therapeutics already. Statins for cholesterol, antihypertensives for hypertension. I think critically, they even say just treatment of depression, quitting smoking. Like we already have a lot of these interventions that we can implement at a population level, which is pretty cool.
Right.
Yeah. I think it's interesting. So I really like the fact that there's modifiable risk factors. But I think one of the posters I saw yesterday, which was Lena Bauer and Francesca Rodriguez. So they looked at the effect of mediating effects of lifestyle activities on cognition, but also social deprivation.
Yes.
Within that. So actually, what was really interesting with that poster is that the mediating role of lifestyle activities was there, but it wasn't as big an effect as the social deprivation aspect. And the authors spoke about how potentially that could result from systemic and structural factors that may actually prevent individuals from being able to take up these lifestyle modifications as well.
Yeah.
And I guess within that, it's also, I think on one level, it's really great on a policy sense. So health economics, you can say, great, we reduce 50% of these cases, and that's going to be huge savings, really reduce the burden on the healthcare system and stuff like that. But I think at the individual level, there's possibly a risk of healthism and kind of thinking that it's your fault kind of thing. So I think actually, as like scientists, when we're communicating these to individuals, it's probably communicating this to the public. It's probably also worth doing it within the context of these other factors as well. That it's essentially, it's almost chance whether if you reduce all of those, and it's still almost chance whether you get it or not. If that's how I interpret that.
Yeah, I mean, there's definitely a huge gap within the Lancet Commission, which is the social determinants of health.
Yeah.
And that's because a lot of the studies they're basing their recommendations on, they just haven't had long, 10-year, 20-year studies on these social determinants yet. So yeah, that's a huge omission within this report at this stage. Yeah. And also, I mean, even though genetic risk factors aren't modifiable, they also influence these pathogens. Like, so what's the interaction between these modifiable risk factors, the social determinants of health, and the genetics? I think it's important to have all three of those together. Not a lot of people are doing that.
Great stuff. And has this study inspired any of you to take actions towards your brain health?
I started actually doing it from the old paper. I already started doing that after. Hopefully this isn't too much of a tangent, but I had a bit of a health scare back in the UK. Not a health scare, but I had my NHS MOT before Christmas. I got told off by my GP, basically.
Oh, right.
Have made some lifestyle modifications, mainly going over to a plant-rich diet, which I found quite difficult to stick to while we've been here. But and then when I got retested, actually a bunch of my my measures had gone down. Actually, LDL cholesterol being one of them, actually. So it's gone down, and I'm just on the slightly high for normal, like on the cusp, whereas before it was very high. So yeah, I've also seen the effect of following these.
Right. Yeah. I think, definitely with the promoting brain health too. Like one of my favorite exhibits within the hall was the portable MRI scanner where you could get your brain scanned.
Oh,
So I went and got that done, and I do have a brain. There's no goldfishes in there.
Great.
It's an MRI.
Yeah.
So you've got a...
Yeah, it's just like a little portable MRI. You just put your head in there, and 2.5 minutes later you get a brain scan.
Oh,
it's like they're designed for like trauma rooms where you can actually just wheel this around to the patients rather than taking a patient to the MRI machine. So yeah, it was a hyperfine sweep, but yeah, it was really cool.
It fits in. So sorry if I just...
No, the implications for technology like that are great for underprivileged countries, and being able to take a portable MRI scanner to places, to people who cannot physically go out to take an MRI would be a very great advancement to detect very early cases if needed.
Yeah, and definitely as we start getting blood-based biomarkers, that can be done within rural communities and underrepresented communities. Like we're sort of bringing this AD research out to the community rather than bringing the community to us, and that has, as I say, like only some people can actually come into the community because they can't get time off from their jobs. They don't have the financial means to get to a hospital. So definitely having these technologies to go into the community is huge.
Since you mentioned the community, today was the first time that there was AAIC for All, which was open to the community. No, Joe went to one of the sessions?
Yeah, I went to it this morning. It was it was excellent to see members of the public engaging with this, because I think that's who we serve at the end of the day. It's these people, and our research exists because of they're also taking part, and it was. It was quite a moving moment. For one of the points where I saw was somebody, I think it was somebody on the panel, said that they were a carer for somebody with Alzheimer's disease, and they were taking part in research not for themselves, but for their children and grandchildren when they're old. So kind of accepted the outcome, but it's like, this is why I'm doing this to help, and that was very powerful. I think it was quite hard not to feel the emotions at that.
Everything we do at the end of the day is for the future. It's not something necessarily we're going to see, but hopefully the future generations are going to have a better outlook over that. And I believe that the two plenaries today were very carefully tailored to also be accessible to the community that was visiting today. So I found that like a very nice touch to end the conference.
Yeah, when everyone stood up and when people clapped for the participants and their family members as well, that was amazing.
Yeah, I mean, AAIC for All is definitely a highlight. I mean, my wife is here and she attended it. She doesn't know anything about Alzheimer's or medicine, but having this opportunity to come in and see what other researchers are doing and aimed at the community to make it explainable to them so they can understand it, that's a huge thing.
Yeah.
Public outreach is important. Yeah.
That's great. So, Roberto, do you have any highlights from the conference that you want to touch upon?
Full disclosure, I am completely biased towards tau and the vasculature, and I'm a basic scientist. I found that there's been an increase in posters regarding tau and the vasculature overall, which makes me very happy. But one of the things that I've noticed overall is that there's an interest, like a very, very high interest in looking as closely as possible at events that happen at the molecular level. I wanted to highlight a talk by Rachel Bennett. I believe it was 2 days ago in the morning. They had this really neat paper that came out this year where they took control and AD patient brains, and they were able to clear the tissue, stain it, and obtain like very high resolution images of tau next to the vasculature. And that's one of like the greatest indicators that we have that sort of pathology. And that kind of went a little bit on to yesterday's plenary by Dr. Tara Spires-Jones, where they have this very high resolution of what's going on at the synapse with tau. So just being able to see the images. I'm also a very high fan of images in papers. I love being able to actually see what's going on. So that interest in understanding very deep down what's going on at that very resolute level, I think it's been a fantastic highlight, at least for us basic scientists.
Yeah, where do you see the future of tau research leading to?
I know there's a big increase in looking at tau as a biomarker, particularly 217. There's been a lot of sessions. There was a very interesting talk today too, by Eleanor Drummond actually, about 217 that they pulled down with an antibody against 217 and saw the interactome. And particularly they found that it interacts with the E3 ubiquitin ligase, one of the subunits. So it would be for targeting specific degradation of phospho-tau. So I know it's going to be a very big biomarker movement, particularly in the blood. And early detection would be the key. Of course, 217 is an indicator of amyloid pathology a bit later on. So I believe that's where it's going to move a little bit forward. And also in finding tau in places it's not thought to be at. I think that's where the periphery is also what we're going to be looking at in a few years.
So I think that's really interesting because the behavioral task that my group works with, the visual short-term memory binding task, there's evidence, and that was what the analysis we showed today was, that we showed on Monday actually. We did a behavioral analysis, but based on existing research that essentially your performance on this task is influenced by tau. So it's really cool that we've developed the remote version, and then you can sort of generate large data sets. Like we collected 370 participants over the space of 12 months. Just by sharing around social media and stuff, and then you can use that to identify these poor performers and then generate hypothesis from that. So it's not fantastic data because it's essentially collected from Facebook, but then like you've got this big, massive data set that you can then start to look at things, perhaps lifestyle factors and stuff like that you can then take further. So I think that's also where the future maybe is other ways where you've got these proxy measures of the and then you can follow up with that and then take it into the lab from that. So.
And that's very interesting, seeing it progress over the next couple of years.
Yeah, it has. Like, particularly that p-tau217. That's really come out, kind of just arms swinging really in the last few years. It's been like a really hot topic at
Yeah, I mean,
AAIC.
definitely, as we saw in the last plenary, p-tau217 age and APOE is like 95% accuracy for
95%
for amyloid positivity.
Wow,
Like, that's huge.
It's very promising, isn't it? Oh, lovely. So, Joe, what highlights do you have from this conference?
I think because I'm quite new to this space, so my background's experimental psychology, where it's traditionally been quite dry research, where you just get people sat in a room making eye movements for like 3 hours, and you measure what you can see in that, and the applicability of that isn't really immediate. So I've also not had that training and stuff. So about working with members of the public and kind of what's really been useful for me this year is getting involved with the peers, and also attending some of the ISTAART training as well, and also the pre-conference stuff. So I really enjoy, and some of it's been quite profound, I think, the way that I think about things now. So the leadership training and skills development on Thursday was really, really good. I'm rubbish with names, but there was a four-person panel of very credible senior scientists. Yeah. And the thing that came away from me that I'd never heard before was this leadership of this servant leadership, or this leadership of servitude, where you're essentially serving the people that you are doing the research for, the people that you collaborate with, and the people in your lab, and just kind of, it's made me think a little bit more as my career develops, kind of this type of leader that I'd like to develop into. But then also some of the other sessions, like working with research participants and thinking about. So we were given a sheet with information about a study, and just thinking about how that may not be very good to people that say they have problems with reading or vision, or perhaps they've got sensory issues with hearing and stuff like that, and just about tailoring it to those individuals. And then some of the other sessions, like working with using AI in your research, from analysis to ChatGPT.
Yeah.
And then also effective science communication as well, which was really, really good as well. So I think that's what I've enjoyed most. Not necessarily the science and stuff's been interesting, but I think also the training that's been available here as well.
Amazing. Oh, that's great.
Yeah.
How do you think AI is going to play in the near future? Because I know it's a very controversial topic at the end of the day.
So this is something I have, because I presented a poster on Monday using AI, but I don't actually have that much of an understanding of what was done. So it was done by a collaborator, Sami Danzo, who's also one of the Bill Gates AI Fellows. So he knows what he's doing, I would assume. But I think it is going to be useful for kind of picking out these patterns in these data sets that you might not necessarily get with, say, frequency stats and stuff like that. And yeah, just new ways of looking at data as well. But then I also think, like, even with things like the ChatGPT and stuff, so I tend to use that on a daily basis, but more as like something to just bounce ideas off or generate ideas, and then when writing, or to give feedback on, say, you write a manuscript and then getting feedback and stuff like that. So I think it's going to help the science that we produce, but then it's also going to be part of the science that we produce, if that makes sense.
Yeah. I mean, while we have AI tools to sort of query all these big data, like electronic medical records, UK Biobank, all of us, what's often missing, like if you just have a newcomer coming to the field without that domain expertise, they find all these correlations that aren't necessarily biologically plausible. So you get sort of overwhelmed by those associations. Then you sort of need the domain expertise to pass what's actually worth following up on. So, again, AI is not going to replace us, I don't think, right? You still need the human in the middle to sort of go through and say, what is actually important to the research we're doing, and, more critically, actually designing what that research is. At this stage, AI can't tell us what the research questions are. Yeah, that's where the human creativity comes into. But yeah, I mean, I use ChatGPT every day. I mean, I mostly use it to help with, grammar and syntax and stuff like that. But main thing I tell machines, like, I'm okay with you using ChatGPT to help you write a manuscript, but that first draft has to be yours. And you have to ask, not just get ChatGPT to explain what, to fix the grammar, but actually tell it to explain to you why it's making those changes so you're learning from it. So it's to help teach, not just to blindly copy and paste.
I like with that, you can also fix the prompts to kind of give them like a backstory, I guess. So like, you're an eminent professor in this field, please read through this written manuscript and give me feedback.
So apparently so they're currently testing different prompting techniques, and apparently that doesn't work so well in the newer versions of ChatGPT. Like, it worked really well in version 3, but
Take
the latest...
a deep breath was one as well, I heard.
Yeah. So, yeah, I mean, that's rapidly changing every day too, which is cool. But I didn't see too much AI stuff here. At least not the sessions I went to.
No, I saw. So there were a few papers where they'd used it for analysis, and then it was just the ISTAART training on using it, which was nice for an overview, I think, and maybe encourage people to use it. Within the limitations.
Yeah, I mean, another example actually. So at the start of this month, I went to another conference on the science of science and innovation, and there's a lot of AI stuff there. But one of the examples there was they're doing more qualitative research, like asking researchers how they're using ChatGPT, and the person doing the research actually does, I think it was cardiovascular research, with a specific statistical analysis and specific instruments. And one of the people was asking ChatGPT how to do this analysis, and was just giving default values that actually didn't make sense. And again, like, just copy and pasting the code without understanding what those values are or why they were chosen, and how that can then influence your results. So that critical thinking that goes into the actual analysis that you're doing.
The human theoretical expertise is required to, almost as if you're asking an intern to do something for you. It has to be sanity checked before you throw it into the wild.
Yeah, that's right. Yeah, one of the things that I found with ChatGPT was that it did, like, was it forecasting, where it kind of pulls out these studies from thin air and uses it in your
hallucinations.
Hallucinations. That's it. Yeah. So that's one problem I ran into. But I do think it is a very useful tool. And it's like, well.
The new version does access the internet now. So you'll ask it a question, you'll see it doing the little spinning circle while it says it's accessing the internet and showing you where it's searching, which is...
That's very exciting.
Yeah, I mean, maybe that's a nice segue into another talk I found interesting, which is actually on scientific fraud.
Scientific fraud?
Yeah, so Suzanne Hendricks from the Pentara Corporation, I think they're developing topic session 3. So they were actually developing this algorithm to basically go through data that's been given back into clinical trials to identify sites where there's actually suspected scientific fraud, where they're either like copying data from the same participant to boost sample numbers, potentially like multiple blood samples coming from the same person, the same MRIs. And basically saying, if you see people recruiting or enrolling subjects into a clinical trial too quickly, like, that's very suspect. But the main findings say, like, if you rank the effect size of the treatment effect by the suspected sites. So, you know, the least suspected at the top and the most suspected sites, you know, of fraud at the bottom, the effect size attenuates towards the null. So this is saying like there's actually potentially treatment effects for drugs out there that could be real but actually been hidden by suspected fraud, because the treatment effect becomes null by including these suspected sites in there. I think, yeah, again, just highlighting how careful we have to be of the people we're working with, and, you know, being very critical of the data we're receiving from, you know, everyone.
This was also mentioned, this was touched on in the ISTAART science communication training, actually, about the, so when you do communicate research, you should always put it into context. So discoveries and known truths should be separated from single studies because of, and not to assume that the people you're communicating with that make that distinction. So for example, if you do have this cool finding in a single study and you communicate that to people and it kind of gets out there into the wild and then it does get retracted, it's kind of already out there and it's going to be kind of, it could frighten people or stuff like that, and it's hard to kind of retract back once it's in public domain and becomes common knowledge.
Yes, yeah. I mean, once the science is out there, we can't take it away. I mean, we can, but as I said, it's still out in, you know, the public.
It's harder to remove a message, I think, or to change it,
Right. And Shea, you've just come from the plenary session that we just had.
Yeah, it was two really great plenaries. Of course, we got Mike Weiner, who's from UCSF as well. Gave a fantastic overview of the major contributions ADNI's had to, you know, AD research. So this has been going on for like over a decade. So it's going into their ADNI 4 data now. So the ADNI 1, 2, and 3 were really focused on identifying novel biomarkers for Alzheimer's disease, particularly CSF and PET imaging biomarkers, and now blood-based biomarkers. But one of the highlights, or one of the things that Mike really highlighted as a limitation of ADNI is particularly ADNI 1 to 3 was the lack of diversity. So it was very much a white, non-Hispanic Latinx white cohort. So ADNI 4, they really brought in a new diversity task force to make sure that they're enrolling more diverse participants. But even then, there's still other issues around generalizability, particularly around education and socioeconomic status. So most people who enroll within ADNI have like a college degree and also tend to come from a higher socioeconomic status. So it's great to see that those changes have been made to increase diversity, but there's still, of course, more to do in the cohorts that we're recruiting.
I think what really stood out about me for the ADNI talks, I'm just, as I say, I'm new to the field and just learning about this bio side, but it kind of fits in with also one of the plenaries yesterday about lower to middle income countries and their involvement in research and stuff. And the fact that the data is available as well without request, that anyone can just access it, and that's led to 6,000 publications. But it kind of it's okay. So they're addressing the kind of lack of diversity within the sample, but by making this data available, it does kind of it enables more countries, lower to middle income researchers to actually access this data and to churn out good papers and stuff like that as well. So that was something that really stood out for me in the ADNI plenary.
Yeah, I mean, I've heavily used ADNI throughout my PhD, postdoc, and now starting my own lab. So it's fantastic.
The very brief snippet that I loved was when he was talking about he himself as a patient of ADNI, when he had the little photos of himself taking the blood test and the cognition test, and it was like there is this great belief in what the ADNI can do and how it should keep going for the future.
Yeah, and then of course Risa Sperling's plenary talk was also fantastic. So more focused around preclinical AD.
Okay.
So a lot of ADNI of course is very focused on sort of symptomatic AD, but of course have this preclinical stage. We've got the build up of amyloid, particularly amyloid, up to 20 years before clinical symptomology. So the A4 study, and now I think doing A3, A2, APEX. I mean, she's got a lot of studies going. But sort of really highlighting that this early removal of amyloid can dramatically reduce the risk of progressing towards MCI and developing amyloid positivity or cognitive decline in the future. So whether this is through secondary or tertiary prevention, and I think where she was going for A2 and A1 studies is primary prevention through risk reduction.
Yeah, I think the idea around that this starts decades before. So the data we presented, we didn't make a big point of it, but actually the mean age of it was 28 years old, which possibly would have been more controversial. Obviously, we're going to investigate it. I'd like to follow it up with a grant to have a look at the biomarkers and stuff. But there was also I think it was Monday, somebody presented some data where they found independent effects of loneliness on memory, independent from depression. And the mean age of that data set was 44 years old as well. So it's just like, actually, there's this evidence indicating that you go, middle age or even before, perhaps, is kind of when people should start thinking about this.
Yeah.
Great. So one of these things that's like, this kind of alludes to, you kind of alluded to it before about the need to kind of recruit more into like these clinical trials taking place around the world. I found it quite striking in John Schott's talk yesterday, when he said that we need just over 50,000 participants to take part in like clinical trials, just to be like similar to, like, comparable to what's going on in like cancer at the moment. And I found it really interesting talking about like the challenges of like recruitment. He went through like what kind of obstacles there are, what kind of preconceptions that people have about clinical trials.
Is research for me? Am I one of these that should take
Yeah.
part? Yeah.
Exactly. I just wondered if you had any thoughts on like what needs to be done in that clinical trials field. Did you go to John Schott's talk? And
I didn't personally myself, but definitely, I mean, we need to enroll more people into clinical trials, have broader generalizability across the populations. And I don't think it's that much of a reach, right? I mean, people go into 23andMe, right, just for curiosity. So I think it's reaching out to people like that who want to be involved in research. And of course, the people who can actually then take place in research may be different from the populations that we need to target. So we've got to get that balance right too. And of course, the biobanks are really going to help with this too. Like all of us is recruiting, 1 million people. The Mount Sinai biobank, like they're aiming for 1 million people now as well, like just completely within their own healthcare system within New York. So I think then the issue is going to be collapsing all these biobanks together and actually sharing data between biobanks.
Yeah, and also like the survey they did talking about like what kind of things that people think about when they take part in a clinical trial, like how long is the clinical trial going to take place? How often do I need to go to the clinic? I think this will raise like interesting questions about how we are going to like work harder in these clinical trials to recruit them. And I think if you do catch up on that, if you do listen back to John Schott's talk, which all of these talks are available to listen back to for 30 days if you've registered for AAIC. And so...
Yeah, I mean, definitely one of the talks that I saw people mentioning on Twitter that I missed was around this issue of brain volume shrinking when they're being placed on lecanemab.
Yeah.
And at least there was a talk suggesting that this is predominantly due to amyloid beta plaques being removed and reduction in inflammation, which does seem to make sense because there was this paradox like, we're removing the amyloid plaques, but the brain is shrinking. Like, is this bad? And this seems to actually, no, it's probably a good thing. It's highlighting that we're getting rid of the plaques and helping to prevent cognitive decline. Yeah. But yeah, I need to go back and listen to that.
Yeah.
There was I was able to go yesterday, kind of touching on the how complex it is for clinical trials. I was able to go for a bit to the sprint mind session yesterday in the afternoon, and I believe the study had around almost 10K people, but how the mortality rate that happened naturally greatly affected like the outcomes that they had at the very beginning monitoring phase, and how the changes were actually seen in the 10 years post their initial observation period. So it would be an issue number, but they made a really great emphasis on how that number really affected.
Great. All right. So wrapping up then. So what have been your key takeaways from this conference so far? It's been the last day. We've come to the end of it. What did you think? Let's start with Joe.
Just about bringing more diversity into the research, the participants, so the data sets are more applicable to different populations, taking into consideration those systemic factors that may stop people from being able to participate in modifying risk factors and stuff like that. So I think that, yeah, for me, it's been around the equity.
Amazing.
Yeah, and for me, it's definitely probably the combination of the Lancet Commission report with Risa Sperling's talk really highlighting that these population prevention strategies can probably really influence this preclinical stage of Alzheimer's disease and reduce, promote brain health for risk reduction. But again, making sure that we have this equitable, personalised medicine approaches for doing that.
Right, Roberto?
I think the main takeaway has been the importance of looking at the earliest changes possible and how all of these affects 20 years before, 10 years before the pathology that we see now. So I think that's going to be one of the main things for actually next year, how people are going to be looking at earlier pathology, particularly in the basic sciences part. I think it's moving a few decades back in time to see what early changes are going to be the pathology of that develops.
Great. Yeah, my takeaways. Yeah, I think I'm definitely going to certainly look into vision loss. I think I can't take my health for granted at this stage. I think I don't really do those medical checkups like GPs recommend. So I think that's definitely something that I'll take away. There's loads of resources out there. Alzheimer's Research UK did their recently uploaded their Think Brain Health Check-in, where you can do this online survey/quiz to kind of talk about the steps you can take to prevent where you can improve your brain health. That wraps up this episode of the Dementia Researcher podcast. Thank you so much for listening. Thank you all of you for joining me today. It's been really great. It's been a really great conference. I've had a really good time with that. So if you are registered at the AAIC conference, you can listen back to the talks for 30 days after the AAIC finishes. But yeah, thank you very much. This has been the Dementia Researcher podcast.
The Dementia Researcher podcast was brought to you by University College London with generous funding from the UK National Institute for Health Research, Alzheimer's Research UK, Alzheimer's Society, Alzheimer's Association, and Race Against Dementia. Please subscribe, leave us a review, and register on our website for full access to all our great resources. dementiaresearcher.nihr.ac.uk.